Hi everybody, good morning. I'm continue doing one room left in the video for it. It's detecting AD lateral movement. This one by TryHackMe. Learn to detect SMB, PsExec, and RDP lateral movement through Windows, event log, and Splunk. So this one, if you follow, I hate this new. So you have discovery, reconnaissance, lateral movement. We have SMB, PsExec, RDP, and a small challenge. Task 1 Introduction. In AD environment attacks, this one is a premium room, so if you don't have subscription you can follow. In AD environment attacks who compromise a single account, rally stop there. They use built-in protocol like SMB and RDP to move from initial foothold to server that hold what they actually want. Like domain controller, file server, and databases, the tricky part of Defender is that these are the same protocol administrators use every day. This room covers 3 lateral movement technique and the log artifact they produce. We start by looking at normal traffic in each protocol, then investigate simulated attack use SMB, PsExec, and RDP. So we have an attacker, we have a workstation. So we do the logs. Prerequisite learning objective in this room is detect ID discovery command through process creation PowerShell script blocks, identify SMB based lateral movement through admin share access pattern, identify PsExec usage through service installation artifact, name it pipe creation. I remember this pipe creation, one of hack the box question stuck on it. Detect RDP based lateral movement using Logon Type 10 and trace multi-hop chain through Logon ID correlation. This is nice technique. Correlate artifact across source and destination system to trace an attacker path. Prerequisites, Active Directory monitoring. There's a couple of the rooms if you want to do them. I already start the Splunk machine. And they tell us make sure the workflow task to use they will give us the query when, and the last one is index challenge. Of course, make sure all time in Splunk that one. Now let's start task number 2. Also discovery and reconnaissance. Also our main focus in this room is that the movement we need to start with discovery as shown in the image below. So for example here, when an attacker first gained access to the network, they didn't know what's in it. They don't know which server exists, which account have elevated privilege, and how the network is organized. So first of all, they have this is, for example, the first compromise host, for example, development station, and then they start discovery command net test, net user, net group, net view, and all of that to check what's inside the network. In this task, we're focusing especially in AD discovery, meaning command that query Active Directory or for information of that. So basically, not usually the local host. So group trust and network general host level reconnaissance like system and for who am I also happen during this phase. But AD discovery what give attacker the map that need the plan their lateral movement. What discovery looks like. For example, here domain trust. For example, use command NL test DC list domain controller in the environment, domain trust, trusted domain. The attacker could pivot to account group, all domain user account group, net group, domain admin dash add domain, member of domain admin group, and you can see all these command usually network at enterprise admin, machine visible to network, share on specific remote system, AD user enumeration via PowerShell, admin group member via PowerShell, or computer account in the domain. So this one is good to know. Commands to filter for them. None of these commands require admin privilege. Active Directory grant read access to all authenticated domain users by default, which means any compromised account, even one belonging to a marketing or HR user, can enumerate every user group, trust, and machine in the domain. This is by design, not misconfiguration. And It's one of the reasons that your movement planning might sometimes be easy for attackers. Uh, this one we saw this table above: require admin privilege, Active Directory grant, read access to all authentic. No, hold on. The table will cover the most common built-in command. Also, attacker use third-party tool like ID find, heavily used by ransomware group like Conti and Fin7, DS Query and PowerShell System Directory Service Directory Searcher class for LDAP queries. Volt Typhoon, for example, the Chinese state-sponsored group, is known for this exact approach. Sysadvisory document the heavy use of command like netuser, nltest, and netsh, and wmic for discovery, a technique known as living off the land, LOTL. Native command don't trigger antivirus and blend in with normal administrative activity. Now, detecting discovery with Sysmon and PowerShell. Of course, Sysmon event 1 capture process creation, where cmd PowerShell command appear in the command, and of course PowerShell 4105 capture script block. I think this one you need to activate, is not by default. Now let's, for example, check, for example, here built-in Windows, and let's see what we have in our system. First of all, we need all the time, we need that. Let me zoom it. Here we're looking for all known command to trace them: group, net, view, net, local group. Of course, we'll get some legitimate commands, so it's not all of them. And here this is not query because we get the command line, the image, and here you're looking for which one is a bit not dodgy. Of course, not all of them 100% tell you. So the results show when the command ran, what host, and everywhere they were executed on, and the user who ran them. The command line feed reveal the command the attacker executed. Scene discovery command execute in extension that isn't expected to have them executed in specific time frame is highly likely to indicate malicious discovery activity. And always remember that context is everything. Of course, when you see this, maybe it's an admin or someone, so it doesn't mean 100% attack. We can apply the same idea for PowerShell block 4104 index. This one also you need to activate it in configuration. So here now we saw that now, but now we need to go to PowerShell command. Make sure it's all time. And let's see what we get in PowerShell command. The message field captured the full skipped block. So basically here we are more interested in this message, and you can see, for example, import menu active get user filter. This is script block, and I think there is I forgot that command that can because the script block is part one, or sometimes they come divided and you need to connect all of them to get the full script. There is a nice query, I remember it was one of the CTF. You can connect all these blocks together. Skip block logging can generate high volume events, so some organizations enable it only on high value target or during active investigation. If it's not available, we can fall back to Sysmon process creation event ID 1 or Windows security 4688. With command line auditing enabled, the trade-off is that Sysmon and 4688 capture the PowerShell a process launch. But if an attacker run cmlet interactively within a session, each individual command won't generate a separate process creation event. Skipped blocking capture every command inside the session regardless, so it's trade-off here. I have a tip here. They said this attacker sometimes encode or obfuscate discovery command to evade detection rules. Base 64 encode PowerShell. If you see this, or CMD character escaping stage generator Sysmon event 1 for the process creation through the command line may show the encoded form script block login is more resilient here because PowerShell log the decoded script. Now let's answer the question. Let's say, what is the first discovery command the attacker executed? We got this command at the time here. So the first, this is 8, this is 3. So this is the future, this is the... This is not discovery command. What is this? This is 8 o'clock. This is like an IT department. This is the workstation. So the idea is this is the part of the attacker access the workstation. This is the IT desk. So the assumption that's how the attack start here. So it's this one. What is the full PowerShell command used to enumerate domain user? Now PowerShell will come here. We need to, because the blocks I said this is I forgot there's a query we can connect them because this is just half of the command. This is half of the command, this is half of the command. So the command start import module active directory, get user filter, select object, same account name. This is not the full one because it get here too and then it get here too. I think let's, if we can open, let's view the full event. Even they tell us here the hint. Check the full message field in event 4104. So we have that one, we have that one. Why it said doesn't exist? Um, why it's not, why is not showing this filter? Why is not showing me this now? It's only 101, so basically it's this one, so it's the same as this one. So this is the full block. So this one is separate. It's my mistake because it's a 101. So basically it's this one. So we don't need to confuse. I think it's this one. Yeah. So my mistake. I thought they combined this and this and this. So the argument is because it's a 101, so it's only one block. This is a different command. This is a different command. But sometimes in PowerShell you get 31 of 3, 1 of 3, 2 of 3, 3, so you need to combine them. So we don't need to combine them here, so it's a mistake. Task number 3, how lateral movement work. Now that we have seen the discovery phase, let's talk about what happened after the attacker has mapped out the network. They know which server exists, which account have admin right, and which machine are worth targeting. Now, every lateral movement technique follow the same basic pattern. When the attacker authenticates to remote machine using stolen or misused credential, then execute something on it. The technique might differ, but the authenticate then execute sequence is always there. Self-compromise, workstation, database, go there. Execute remote service creation, WMA process spawning, remote desktop session, lateral movement. The source and destination model. Every remote connection creates artifact on two machines. One is the source where the attack initiates the connection. It also only sees which credential were used and which target was chosen. The other is the destination, where the session land and action happen. The destination see that someone connected and why they did. So basically now we have a source where the attacker initiate the connection, credential used, target chosen, tool used when it happened, authenticate, process execute, destination, where the session land and the action happen, who connected when it happened, what they did, and we have correlation both. Logon type, the first thing to check. Logon type 3 network login. It's when known SMB, PsExec. What it tells us, remote access without interactive session. 7, unlock reconnect. It's an RDP session reconnect or workstation unlock. Type 10, remote interactive RDP full desktop session. Type 10 is straightforward because it always means RDP. Type 3 is tricky because SMB and PsExec both generate type 3 logon. So we need additional artifact to tell them apart. We'll cover those in the upcoming tasks. A note here, if an attacker connects via RDP with the same account already has an active or disconnected session on the host, Windows reconnect them to existing session instead of creating new one. This generate type 7 unlock logon instead of type 10. During investigation, if we see type 7 with a remote IP address, not the localhost IP, that indicate an RDP reconnection, not a physical workstation unlock. Keep this in mind when searching for RDP activities. Filtering only for Logon type 10 will miss this reconnection. Also note that a reconnection assigns new Logon ID, even though the RDP session itself persists, so Logon ID based correlation can break or disconnect or reconnect boundaries. Now the event we look for them, post 648 tracing the source. Event 4648 login using explicit credential fire on the source machine when process use credential other than those of the currently login user. For example, as shown in the screen below, if Liam pattern run net use connection to, for example, to this machine, user looks relevant, switching user, event 4648 is logged on the target, the source machine and record the original account. So we have this ways that for 6 a login was attempted using explicit credential, and we have the user and then account whose credential was used. So basically it tells you exactly what happened. This tells us directly which machine initiated the connection and what credential was used. Most destination side logs only show who connected, not who was sitting at the keyboard when the event occurred. Now if we go back to process creation sysmon event 1, also capture net.exe process with a full command line, including the target server and the account specified in the dash user flag. For example, here we have process create, we have the image.nes, then we have the command line full of it, and then we have the user and we have the parent and parent command. Together, these two source side events provide better context for the same activity. And now we give us a warning, event 4648 only fire when credentials are explicitly provided, such as net use dash user run as. or entering credential in RDP dialog. It doesn't fire past the hash, past the ticket, or keyboard single sign-in, because those techniques use cached credentials without explicitly providing them. So it's another thing to take note of it. Normal vs suspicious, same event, different context. Now we have the factor, like for example, source IT admin workstation, likely legitimate, with investigation marketing workstation that we saw here when we saw this one in IT, and this is user workstation. Now account and IT admin, and then we have accessing admin share. That's not normal. Business hour 2 a.m. for example on a Saturday. Server the admin normally managed workstation, button single server sustained session, rapid connection for many servers. Why lateral movement succeed? Password reuse across local admin account mean that a compromised credential can unlock many machines. Microsoft Labs is designed to prevent this. Shared administrative accounts, overlay permissive group membership, bad network segmentation between hosts, leaving RDP enabled on machine that didn't need it, widen the attack surface. Now let's ask very quickly this question. What logon type in event 4624 indicate a remote desktop session? Event 4624, that's a logon directly. We talk about this because if it log in, I think it will be 10 because an RDP full desktop chain, and we have logon 4624. It's I think that one is direct login. It's not a reconnect. It's not 7. It's not 3 because that's no. This one a reconnect. It's a 4624, so it must be the 10. It's a direct connection. No, it's a 10. It's a direct connection. The 4624, it's a direct. What event ID logged in the source system record when the process use alternative credential to connect to remote? This one we talk about it just now at 46 something. Where is that for? This event of 4648 because are explicit provided, and the question is alternative connect. So we go to that one. Task number 4, detecting SMB lateral movement. SMB is the most common protocol used for lateral movement, and it's also the noisiest. Every time someone maps a network drive, open a shared document, or prints to a network, print SMB is involved. Now we have the famous admin share that you see them C $admin $IPC created by the service at boot. This share leverage SMP protocol port 445. The C $maps to the root of the system drive. Addition drive follow the same pattern. Admin $point to system root, and IPC a logical share for inter-process communication via a named pipes, essentially for remote RPC calls. Now, regular users don't access this during normal work. They use normal share like marketing, whatever names they use. As, an APT group documented by 10 Micro in 2025 used admin share extensively during their campaign across Southern Asian government network. They authenticated with stolen credential via net user target the C $share. Copy malware to the target, then created. We can see what they do. Command sc the flag txt copy. Oh, you can see all of that. Investigating suspicious admin share access. Now we're doing event 5145 share access. Now let's check that one, and let's see what this one will give us. We're going to 5140 share, and we're looking for the admin share if that was accessed. And now we have source IP, we have the host, we have the time. This is 53, 57, 58. Same user, Luke Sullivan. And now this dev, this is for the dev, this is HR SQL, is a bit different. Event 4140 give us everything we need in single event: the host, the source ID, the user, the share name. The results show an account accessing admin on multiple servers from single IP. Yeah, that's they give us same IP, different servers. A single source IP accessing admin on multiple server and workstation is a strong lateral movement indicator. But how do we know this actually is suspicious? Let's check the baseline activity of the user. So for example, we know the user, so let's see what this user really normally do. We know the user is log7, so let's see what this user normally do. Does he access normally the share? We keep in the same for 140. Now this user, remember, we're looking for the past one. This one is the 65357. This is the past 55560. So before he only accessed the IT and IPC, but now is switching to these ones. Normally this asks the user who only has IT share, so it does make sense here. So you asks the IT share from his workstation. 50.10, we can see it there. On the other hand, seeing the same user accessing multiple admin share of different machine is a short time frame from single IP, not, you can see attacking admin, and then the 10 IP, this is, I think, is same IP, this is 27, admin different, SRV, WS, SRV. So, tracing back activity to the source. Now that we have confirmed the share access is suspicious, we need to investigate the source machine. We have the source address IP, but we need the host name to be fought our investigation. In Active Directory, every computer authenticates with a machine account. That machine matches its host name as a dollar. We can use this to map any IP to its host name. We have the source IP, we're given the $1. We have the source user, that's the address. Now let's see if we can figure out the host machine. And we find it, he got for WS. What WS is? Marketing machine or something. The user ending with dollar reveal the machine host name, drop the dollar suffix and you have the host name. So basically host name is thm-maktws, so we have the host name. So we got now trace back. Finding the command and the source. The source host name tells us something important. From the baseline, we know this user is an IT admin who normally works from TryHackMe IT desk, but their credentials are being used from a completely different machine, a marketing workstation. An IT admin has no reason to be logged into the workstation, which means someone on that machine likely has this user credential. Now we have the host name. Let's see all the command for the share admin. So let's go there. Let's open a new window so we can get everything right. Make sure it's all time. We need to put a host name. The host name without a dollar. Oops. And now we can see all these command, and you can see log7 password. You can see it's what it's doing. Now we can see the active command, the tool used to access the shared user who run them, and the credential in the command line. The user feature who was sitting in the keyboard while the command line revealed the compromised credential they used. These are two different accounts, which is a key indicator of a credential misuse. If we search event for 648 explicit credential usage on the source machine, we'll find a corresponding event for each shared connection, confirming the same alternate credential we used against each target server. Now, tip: the net use command is just one way attacker access admin shares. C2 framework like Cobalt Strike and Metasploit have a built-in SMB model that connect to shares without spawning net.exe, meaning they won't generate sysmon event 1 process creation event. In those cases, event 4648 on the source machine can still reveal which credential were used and which server were targeted, even when the command itself doesn't appear in the process creation log. Event 4114 destination site also still fire regardless of how the connection was made. Now let's see now what we can do. We already did this. What account was used to access the admin share? Here, what account was used? Yeah, Luke Sullivan. And then next question is which user account was responsible for executing the lateral movement command? Remember, we traced the source of the machine to who? This one, Michael Smith. Now let's go detect. Now we're going to how many we left? Hey, how many tasks in this room has? I'm getting tired. Ooh, 5, 6, and challenge. Oop. Now detecting PsExec lateral movement. In the previous task, we looked at true admin share access through net use. That approach let an attacker copy file and browse directory remotely, but it doesn't execute anything on the target. PsExec changed that. It's a system internal tool that combines SMB admin share access with Windows Service installation to run command on the remote system. It's worth studying how PsExec works. Let's see first how PsExec works. When an attacker already has authenticated SMP session void net use and run psexec.exe back for target cmd.exe, the following happen. PsExec connect to the target admin share. It copies service binary PsExec svc to the target Windows directory. It create and start a new Windows service on the target system event 7045. The service create name pipe stdin stdout stderr communication sysmon event 17. That service executes whatever command that attack specify one destination and PsExec remove, and usually this you find for CTF like volatility or something that asks you for this question. Event 7045, a new service was installed in the system log is the signature artifact of PsExec. So you're looking for this event Logon destination machine. This is what distinguishes PsExec from plain SMB if you want to distinguish between them. So this was a nice diagram how PsExec work. You have a source, connect to admin share, copy PsExec svc, create and start PsSVC service, execute a command, return output command, and you can see that. Why attacker use PsExec is a legitimate administration tool. Sysadmin use it daily to push patches, run script, and troubleshoot remote machines. From protocol perspective, PsExec traffic appear identical to normal SMB administration traffic. The only difference is context, which account from which machine and what time and how it was used. An example with a spider, the group behind Riot and Conti ransomware used PsExec extensively for deployment. In incident documented by Red Canary, they would compromise one machine, harvest credential with mimic cards, Then use PsExec to push ransomware to every reachable server in minutes. Now for investigation, now we're going straight to the 4705 to make sure the machine spawned the 47 process. And now we're looking for the service file name, and now we got it. Remember we said it spawned PsExec SVC, and you can see it was there and launched demand start local system use mode service and in the machine host. In its default configuration, the service name is PsExec and the binary path is Windows PsExec to the root Windows. So by default PsExec run and the remote command as authenticated user. When run with -s flag, this service run as local system, granting system level access on the target. What command did attacker run? Once we identify the PsExec service through the 7045 and the host was created on, the next step is to find what command the attacker actually execute. Now here, since is a service that spawned attacker remote command, we can use process creation event sysmon event 1 and filter the parent image. Parent image, we have it PS server, and we have the host name, we already got it. We have the host name from here. We got the host name is SQL SRV, and then we have the image, so you see what anything spawned from that direction. And we can see the command and who am I, Epiphone and local group administrator. Now the parent image feature, which process spawn each command. That is when known investigation, you're looking for the parent and the image. So this one the parent, and we have a command line spawn that one. Name pipe, this one artifact sysmon ID 17, you can keep that one. The parent image, and we just look for the pipe 17 and we keep the parent, and then we can get the information and we can see the pipe. Where's the pipe? You can error std out std in, you can see them there. PsExec create pipes with name like hostname pipe stn st out str. These pipe names are useful because even if an attacker rename the ps binary, that's the important part, the pipe naming convention often remain unchanged unless they modify the source code, and most people may be lazy to do so. Now tracing PsExec usage using event 5145. We have identified the service and the command it execute. Now we need to identify who initiate this and where they connected from. Now event 4145 data file share goes further, where it logs the specific file and object access through that share, which are shown in the relative target file name. So we have the host, but now we need to verify, we need to investigate. Now we know the host name is the SQL server. So now we go in event 5145. Now let's see what this one will give us. You see, now if you are in CTF on exam and a question related to PsExec, you can see all this query. You just save them in your notes and you get all the information. And we can see the user Sullivan, the source IP, the share name, a relative target name also there. Notice that the name and pipe name contain the source host name, revealing which machine the attacker is operating from. So you can see it's operating from you can see WS. That's interesting. So the question is where the attacker operating from, you go to answer. So this one give you the target and this one give you the original. Now tip event 5140 and 5145 require audit file share and audit detail file share to be explicitly enabled via group policy. If we search for those events during investigation and get zero result, it doesn't necessarily mean the activity didn't happen. It may mean the audit policy isn't enabled in that environment. Now, detecting PsExec source side. Once we find the command executed and service name, we can easily track the source host from which PS was executed. Sysmon event 1 capture the process creation in full. Let's open another one. Uh, I think the source we got it is this one. And then we can see the original in the host what was the command that was executed. So now we started from this, we got the confirmation, then we got where the attacker waking from, the target, and then we got the pipe name, and then we got from here we got the source where you start from, and this one will give you the command original. Now, hunting for renamed PsExec. Attacker knowing that security tool like PsExec by name, PsExec-r flag lets the operator specify custom service name. So running PsExec-r renaming PsExec and target CMD create a service called a renamed name instead of the original. Other tools like InPacket, PsExec PY, or Cobalt Strike PsExec model generate a random service name by default, but event 7045 still fire regardless of the name. The button to look for is any new service with service type of user mode service and service start type of demand start. The service name and binary might differ, but the demand start user mode service signature remain the same. What was the destination host the attacker target? This question about destination host. That's the destination host, I think. Uh, yeah, that's the destination host. And then what is the first command that the attacker executed from the source machine, a source machine using PsExec? The first command, we found it here at the time 3:45:31. Huh, it's like a time is this is 51:31, so it must be this one. No, task number 6, detecting RDP lateral movement. RDP give the attacker full interactive desktop session. Remember we talked about this before, and more interesting primary detection artifact is the 4624 and the login with login type 10 remote interactive, logged on destination, it records the account name, the source IP address, and the session timestamp. While SMP and PsExec both produce type 3 network logon, a successful RDP session produced type 10, making it immediately distinguishable in the security log. However, an LA introduced a variant with and standing. Modern Windows enable network level authentication NLA by default. With NLA, the user authenticates at the network level before RDP session is established, which generates a brief type 3 logon right before the type 10. If we see a type 3 from the same source IP appearing second before type 10, that's an NLA prelude, not a separate SMP or PsExec connection. The lab environment in this room has NLA enabled, so you may see type 3 event alongside type 10 logon in your query result. For example, attack black suit, the successor to wire ransomware covered in the updated CIS advisory rely on RDP as primary lateral movement. According to the FBI Black Suit, actor combined RDP, PsExec, and SMB to move through victim network and, in one confirmed case, use the legitimate admin account to reach the domain controller directly. Normal vs suspicious RDP, for example, typical workstation server, yes. Why IT admin RDP from their workstation to manage server. Workstation to workstation, rare. Regular user don't RDP into each other machines. Helpdesk might, but only from designated IT workstation. Server to server suspicious. Server don't initiate outbound RDP on their own. If a server is RDPing to another server, someone is sitting inside the interactive session and that server is pivoting outward. No, investigation RDP we go, process creation, no, we wouldn't normally jump directly into RDP log because they can very noisy. Instead, let's say we receive an alert for discovery command being executed in your domain controller. We start looking at the process creation log. We done of this one, so we can go. So basically here we go the traditional way, looking for the command line. Is an example, for example, for that host, and now we can see netexec was that in the host and for user that user. Now we can see a discovery command being executed in domain controller. The Logon ID will tell us which session this command belongs to. Let's use it to find. This is the nice trick to go backward to the source. So we can get this one. Let's see what it gives us now. This one it tells us AD looks relevant. Logon type 10, that's an RDP 10 IP. We have two login for some reason. Let's see what is the logon type field shows 10, which means the attacker reached the domain controller via RDP. We can check the source network address feed to know where the attacker connected from. Yeah, we have this one from .20. Now let's go backward to get our host name. Now this one doesn't give me the IP. Let's to and now we got from SQL SRV machine. The user ending with $reveal the machine host name, finding evidence of outbound RDP connection on the source. When someone initiates an RDP connection from a machine, mstsc.exe with the Windows Remote Desktop client run on that machine. If sysmon is captured the process creation on the host, we can search for it. Now let's go backward now. We already got the host. Now what we doing, let's get the machine we got there. And now we got event 1, we're looking at host and we're looking for an RDP process. And we got it. We have the process and a command line on it. This confirms that someone launched an RDP connection from the server targeting the domain controller. So now we can see we start there, and then we got the confirmation that in this user machine, TryHackMe Studios launch it from here to the domain controller. Now we can trace how the attacker got into this server in the first place. Trace how the attacker reached the intermediate server. Using the same correlation technique, we take a Logon ID from PsExec process and we go backward. So we got this one, the new Logon ID. So remember, this is what interested us. Source server, because source server, it must be this one, I think. Or am I wrong here? I'm running wrong. Using the same correlation technique, we take a Logon ID from MS process and match it against eventful 624 and the same server. Hold on a minute. Here we same server. We're talking about this. Logon Type 10. We can see another RDP login. I'm getting confused now. So these are two RDP, one here and then this one. This logon shares another RDP, and we have the uh, so there's two RDP. We can see another RDP login, but this time from a different user and different source than the one we saw in domain controller. Look 7 50.12. This is 3020. The attacker started compromise workstation, used RTP to reach the server, then from within that session open another RTP connection to the domain controller using a different more privileged account. This pattern is called RDP chaining, and it's common when attacker pivot through intermediate machine to reach sensitive target like domain controllers. Each hop uses RDP, but the source IP address changes at each hop because the connection originates from the intermediate machine rather than the original workstation. The diagram below shows the RDP. So workstation, RDP hop 1 to the server, RDP. So this one, the first one, this is the second one, type 10. Okay. What is the source IP address of the RDP session that landed on the domain controller? Um, that landed in the command the controller. Yeah, this is the last one. This is the last one that landed in the command controller. That's the one for the machine. So for the controller should be this one. And tracing backward through the chain, what is the original source IP? The original, we saw it somewhere here. This one. Now, oh, let's investigate now the final one because I'm really getting tired about it. It's a bit long. The SOC team received an EDR alert for suspicious service installation SVC update on this user. The service name doesn't match any known software deployment and no change request were scheduled for that evening. Your task is to investigate this network movement activity and trace it back to the origin. The index is challenge. Let's go back to challenge. Suspicious service installation. We had SRV machine. What machine is talking about? HR SRV. And then he said installation process SVC update. BC process 1. We can see the images. This here, the image. Oh, we can just search for it. What's the question is, what's the full path of the service binary that was installed in the target? Hmm. Where's the command line? Oh, this is the SMB share file. File path Windows. What's that image things? Member name I. Oh, there's no image here. Yeah, why you don't find the image? So we can see the image, and then what it said the question? What is the full path of the service binary that was installed in the target? What exactly that the hint is giving us? Service file name event 7045. I think this one is about SMB, that's why they go into 7045 things. This is PsExec. Oh, it's a PsExec. Interesting. Let's test that it's a PsExec. Is it a PsExec attack? SVZ update. Yeah, it's a PsExec. I didn't see it here. Let's see where. Because if it's CPXF, we can see service file name. Oh, the service type and the service start type. Where is the service? Yeah, you can see the shares. Service. Where's the service type? And that's this one. That's why we didn't see them. They are not all here. Let's see. Service. Yeah, we have a service file name and we have a service start type and a service type service. So that's why. So this one is this task challenge is about PsExec. So you can see it's coming there. So and we can see it here. We already saw the service. You can see the file path is Windows. So this challenge is clearly it's about PsExec, not SMB. Why is not what's the full? Oh, they want us use this format. And then what account was used to access the admin share on the target server? Now we can come back to SV. We'll get all the queries to look for us nicely. So so basically we knew now we're doing with PsExec, so we can just follow the same pattern that we did before. We can just destination host. We have a destination host. And then after that, remember when we checked the pipe. Let's get the pipe one. We can do them. I like these queries. It's nice. It's like it give you all the information. Now this one give me the pipe. Why it doesn't give me the pipe? Interesting. Event 17 image PS. So the image changed or something. So the no result. Why I'm getting confused now? Destination host. What's the question? What account was used to access the admin share on the target server? For the It's a PsExec. No, it's not a PsExec, but it's demand starts as a service start. Why I'm confused now for the moment. Where is that PsExec again? This is RDP. Which show a relative target name. This is the pipe. Yes, demand start local system. What I'm doing wrong here? Otherwise, it's not a PsExec, or I'm missing the host or something. What I'm doing wrong? Oh, it's not a PsExec. I think it's an SMB. I'm confused now. It's an SMB. Why they tell us to look for that SMB share? Let's try the SMB share. Uh, now we go into SMB, but why? I'll come back to this one. Let me trace the SMB quickly. So we have the SMB access to admin. We have the challenge. Oops. User account, we got it, is Ryan Chen. Let's open another one. And this is the normal for user, but we need to investigate further. And then we got that, and let's do that one. We're still in challenge. Sorry guys, I'm getting it from source IP. We got the source IP. It's a 15. And then the next one we said since interesting admin. So for example, we go into that admin. Let's see first for what this user did access. IPC admin, that's the admin that one. We can open another one to confirm it has a city count time. Source host name, we got the host name HR. So it's not a PsExec. I'm getting for a moment totally confused. Windows challenge. Uh, Let me go back to the question. What account was used to access the admin share? We already got this one. Event 5140, we already got that one. Ryan Chen, let's follow the question for a moment before we jump. What is the source IP address of the lateral movement to SRV? Oh, that's 1, 10, 15. We got that one. And then what is the first remote command the attacker execute on target machine? Parent image to find the command. Yeah, we got that one. Parent, why I'm getting the wrong information here? SMB, this is an RDP, PsExec. Why our command relate nothing here? Said event challenge admin. Maybe is not admin. What did this guy accessed? IPC admin SRV, and he went to the DC IPC. Huh. Tell me it's an IPC. I'm confused for a moment now. It so the SHR SRV, and you also asked IPC the DC. SNGF, he didn't do the share. The command appear in this one. Okay, which one we doing now? Event code 1. We got this one. It means which the first remote command the attacker execute in the target machine answer format command line field. So if we get this one, the target machine SRV, which is this is from the HR, he came from the HR, and he targeted the SRV, so the command should be this one. Let's have the format of the TryHackMe answer. What does the format doesn't look is correct? I launched that SCV update. Command C, hostname, who am I? I'm getting confused. What host did the attack originate from? This one you can. We already got it. Is this one? Why the command line? I'm confused. Use sysmon event ID and filter by parent image to find the command run by SVC update service. What format TryHackMe is doing? 1, 2, 3. forward slash dash dash. So it is not this one. I think I'm confused for a moment. I don't know what I'm doing. The RDP, where is that SVC? We got the Sysmon ID 1. What the house will command? But it's not a PS. We tried this one and we couldn't get anything. Destination host. This is the source host. Destination is the SRV. But it's not a PsExec. I'm getting confused now for total confusion. No, it's not PsExec. We will just filter by this thing. So we filter in event 1, parent image SVC update, the host HSRV. The first command is this one, who am I ipconfig. So what the hell we got here? Host name and who am I and ipconfig. Host name and who am I and ipconfig. This is the same. This is just so we can just add the host and SRV, HRSRV, and this one is what it sent from the original. So basically this is the original command, and this is what run inside the host itself is on HRSRV. This one is from the original system, from the HR, where the attacker start in HRWS, and that's what he run, and then it is target the HRSRV. So explain the question, Ryan, and then it start from this. So that's the machine, original machine WS. We know the target is HRSRV, and then inside the machine, inside SRV, if we the parent image for that process, I need to check this one again. Then we can see the command. That's the format. It's the same format of this, to be honest. I'm just the format a bit got confused for a moment. So what that tells us, this the target is HRSRV. We got it from 704, and that's why we didn't find anything there. We got the IP chan, and then we have the access the IPC. This one not the admin for some reason. We got that one. Where is the when I change it to IPC? When we change it to IPC, then we get the original command. That I hope, guys, I'm right. If I'm wrong, please let me know in the comment. Now, conclusion, task this room covered three lateral movement technique, SMB, PsExec, RDP, how we shall authenticate against Active Directory and the trace key, They live on both source and destination machine. Takeaways: discovery command in process creation log are often the first indicator that trigger a lateral movement investigation. Spotting elimination early can lead to catching lateral movement before it reaches sensitive target. The same event for 624.5 for legitimate admin and an attacker. Source verification account timing and target pattern and what distinguish them. Type 10 mean RDP, type 3 cover SMB and PsExec, where additional artifact event for 5140 event 7045 that we went missing. 6 months event 17 separate the two. Event for 648 ties the initiating user to the target, connecting by recording alternative credential used on the source, but only for explicit credentials, not past the hash or KBOS SSO. Admin share access admin and C from an expected source. Yeah, I didn't test that C. I do the IPC. How about the C? But the C will get the IPC too. Oh, now we have a whole bunch of the C. No, let's leave it in IPC for now. I need to verify this IPC1. No, this IPC, something is not right here. Admin share, admin and $C from unexpected sources is strong lateral movement indicator event 514 capture. Access with share and firmware system event 17 detect characteristic PsExec pipe pattern that persists even when the binary is renamed. Event 7045 service installation is PsExec signature artifact. Link RDB session with Logon ID and look for MSTSC exec. Let's see for final. Let me see what these things do. Event code 1. We have this host name. Yeah, we've been doing with the PsExec. You can see PsExec system internal. That's where the confusion all start, and that's the command. So where did IPC came from? Oh, the IPC is wrong. It was filtering in IP config. So this command line, I don't know. This is like useless. Why we didn't get the share? Because it's not a share. It's an IPsec. This is not an SMB. But why we didn't get the result for that? It was renamed, I think. That's why we couldn't find it. It was renamed. That's why the whole it was renamed. Yeah, because it's an PsExec but was renamed to SVZ update. That's why I think we didn't find this. So that last IP, this one, it doesn't make sense here. Because just it will give you the. Sorry guys for the confusion. I don't know. I hope it helps someone. Let me know what you think in the comment. And yeah, it's an IPsec. I think it was renamed. Thank you very much and have a good day.